This video is a review of finding volume of different figures. So in number one, we want to find the volume of a hexagonal prism. So remember that our volume is equal to the base area times the height, and the base area of a hexagon is 1/2 apothem times perimeter. So to find our apothem, if we draw a triangle from our hexagon, remember that it's going to split that side in half. So if the side was 12, it splits into 6 and 6. And that our angle at the top of the hexagon is 30 degrees, which means your apothem is the S√3 side, so it's going to have a length of 6√3. So we know our apothem is 6√3. The perimeter, there is 6 sides times 12, so that's going to be 72. So we would have 1/2 times 6√3 times 12 times the height of 28. It's the distance between the two bases. So put everything in your calculator except the √3, and we get 6,048 √3 meters cubed. In number two, we want to find the volume of the square pyramid. So we already have our height is 24. So the volume of a pyramid is 1/3 base area times height. To get the base area, it's base times height times the height of the pyramid. So remember the two h's are different here. So the square sides 15 and 15, so the base third times 15 times 15 times the height of 24. We put that all into our calculator, and 1,800 centimeters cubed. In number three, find the volume of the cylinder. So the volume of the cylinder is base area times height. Remember that your base of a circle is going to be pi r squared times the height. So we would have pi 9 squared times a height of 5, which would get us 405 feet, or pi feet cubed for our volume. Number four is a cone. So in a cone, the diameter is 30. That means it splits the radius into 15 and 15. 25 represents our slant height. We want the regular height. So in order to get the regular height, we need to do Pythagorean theorem. When we do Pythagorean theorem, we have 25 squared equals h squared plus 15 squared. 625 is equal to h squared plus 225. So we get 400 equals h squared, which means h is 20. So our height is going to be 20. The volume of a cone is 1/3 base area times height. Remember, in a cone, we have a circular base, which means that base area is pi r squared. So we would have 1/3 pi 15 squared times the height of 20. So when we multiply that, we get 1,500 pi centimeters cubed. In number five, we want to find the volume of a frustum. Remember, that is just a cone with part of it cut off. So I'm going to draw in my triangles. I need to do similar right triangles to figure out what that length in the triangle is going to be. So we would have x over 6 equals, this whole side is x plus 10 over 9. So we cross multiply, we get 9x equals 6x plus 60. We can move the 6x over, so 3x equals 60. So x is 20. So now that we know that, we can do Pythagorean theorem to get the two heights. So the first height of our triangle, we're going to do 20 squared equals 6 squared plus y squared. So we get 400 equals 36 plus y squared. So we get 364 equals y squared, and that simplifies to 2√91. Then we also need to find the height if the whole cone was there. So we do Pythagorean theorem with the 9 and the side of 30. So we have 30 squared equals 9 squared plus z squared equals 81 plus z squared. We can subtract 81 and we get 8 809. No, we get 819 is equal to z squared. And when we go to simplify that, we get 3 root 91 is equal to z. So to find the volume, we're going to do the volume of the bigger cone minus the volume of the smaller cone. Remember that volume is 1/3 base area times height. So we would have 1/3. The base area of the bigger triangle would be pi, or the bigger cone, if it was there, would be 9 for the bigger base. So pi 9 squared times the height of 3 root 91 minus 1/3 pi 6 squared times 2 root 91. When we multiply that out, we get 81 root 91 pi minus 24 root 91 pi. Because they both have pi in their answer, we can subtract and we get 57 root 91 pi inches cubed. Number 6, this is a composite figure, so there's multiple shapes that make this up. So in this one that kind of looks like a pencil, we have a hemisphere, a cylinder, and a cone. So if the diameter is 12, that makes the radius 6 for the cone and the hemisphere. We can use that to find the height of the cone. We would have 10 squared equals 6 squared plus x squared. 100 equals 36 plus x squared. 64 equals x squared. So x is 8. So if we know the radius of the hemisphere and the height of the cone, we can subtract those from 21 to get our height of the cylinder. So our height would be 7. So now we can find our areas. So when we go to do that, we need the area of the hemisphere, which is 2/3 pi r cubed, so 2/3 6 cubed, plus the volume of the cylinder, which is base area times height, so pi 6 squared times 7. And then the volume of our cone, which is 1/3 pi 6 squared times 8. So the volume of our hemisphere is going to be 144 pi, plus the volume of our cylinder is 252 pi, plus the volume of our cone is 96 pi. So we can add those together. And we get 492 pi meters squared for our total volume. Last one, number 7, we have a cube with a square pyramid on top. So if the cube has a height of 10, we can subtract that from 22 to get the height of our pyramid is 12. So we're going to do the area, or the volume of the cube, which is base area 10 times 10 times the height of 10, plus the volume of our pyramid, which is 1/3 base area, so 10 times 10 times the height of 12. So when we multiply, we get 1,000 plus 400, which is 1,400 millimeters cubed.